Hello everyone, my name is Abdullah Ibrahim, student of Skyfi Labs. Um, we, after designing this tall building at the end of this course, we designed a mat foundation. So this mat foundation is for the tall building that we designed on E-tabs. So this tall building, it has 23 sections like I said earlier, and so from the we took we from the ETABs we we took the load and the sizes of the columns. We did this through because actually the load that we needed is from the bottommost floor. So we went there and took the loads, but on the ETAB software, how you'll get it, you'll have to go to the model explorer, then you'll go to the tables, then you will go to the result. From the result section, you can take uh, frame result, column forces, then you'll see the details there. So sorry, you'll see the loads there. So you'll have to filter and take that of the bottommost, that is, maybe let's say the first one, because we use the first one. So you'll take that of the first one. So you'll go to the details, on the bar. You'll go to the details tab, and then you'll start detailing so that we can get the column details. Because if you, after getting the load from the column forces, you cannot identify which load is for which column. So you'll have to take the um, column details also. So after you finish the detailing, you can get the column details. Um, then you'll match the name of the column with the load that you got from the column forces. And then from uh, from the model explorer also, you'll have to go to model, you'll go to story 1, and column, you'll double click on the column so that you can get the column sizes also, because you cannot get the column size only if you go through this. So you'll go to model explorer, you'll go to model, then you'll go to column story 1, and you'll see all the columns, and then you'll check the column sizes. So after the column sizes, then you'll match the name of the column that which you got from the detail, from the column details. So that also, and then you'll calculate the subgrid modulus, which is soil bearing capacity by the allowable settlement. And then, because the 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 bearing capacity was given to us, I think 300, and we calculated. So we went to the safe software and then used all the details that we got from the ETABs, so to design this foundation. So first of all, we defined the the column sizes and the slab thickness, like that. So after that, and the reinforcement and everything, we defined everything. So after defining, we we drew the slab, and then we put the columns. We put the columns based on their sizes, because we had two sizes. So we started with the smaller sizes, which are at the edges. We put them, and then we put the bigger ones in the middle, and then we put the dead and live loads on each of the column, because all of them, they have different loads. So we put the loads on each one, and differently. We didn't select them all. We put the loads differently. After we put the load differently, we put the soil also. We put the what do you call it? Yeah. So what do I have? What do I have to say? Um, the soil details. Yes, we put the soil subgrade properties. Yes, and then the column properties also everything. Then um, uh, then we run the analysis. Yes, after running the analysis, we found out that the slab thickness was too low, and for that the punching shear was more than one. So we had to change the thickness. We had to change the thickness of the slab. So slab or mat. So we changed it to 1,200. After that, we run the analysis again, and then the punching shear was less than one, which was okay. So that was how we did this project. Okay, thank you very much.